Hello, friends. Let's discuss enzymes. So, enzymes, let me get a different color. So, enzymes are a specific type of protein, and their function is that they catalyze or speed up reactions. So, you need to know that catalyze means speed up. So, enzymes affect reactions that would occur naturally on their own. So enzymes don't cause reactions to happen. They're going to happen anyway. The enzymes just catalyze and speed up the reactions, okay? So how do they work? And I'm going to show you a picture. But basically what happens is you have an enzyme, and the enzyme has this area on it called the active site. And what happens is enzymes and what are called substrates. So substrates are what is basically the reactants of the reaction, so what you start with. So substrates and enzymes are floating around in whatever liquid, like let's say we're talking about like the small intestine, because there are a lot of enzymes in the small intestine. So enzymes and substrates are moving around, and what happens is the enzyme and the substrate will collide because they're both moving around. And so they will collide. It's not a collision that's like super crazy. It's not what you think of. It's, they just end up colliding, and the substrate will fit into the enzyme via the enzyme's active site. And so substrates are specific to the enzyme. So if we're talking about, amylase, amylase is an enzyme, and only starch will bind to amylase. So the substrate is specific to whatever enzyme it has. Okay, so the enzyme and the substrate will bind via the enzyme's active site. Once they bind, you have what's called the enzyme substrate complex, which looks like that. And then what happens is the reaction occurs, the products are formed, and this is called the enzyme product complex, and then the products are released. Okay, so how, again, enzymes are catalysts. They speed up the reaction. So how do they actually speed up the reaction? They do that by lowering something called the activation energy. So you guys are probably familiar with like what activation means, like to start something up. So in general, for a reaction to occur, there has to be some energy. Especially if we're like building molecules, that takes energy. Okay, so normally, if you look at this graph, the red curve represents a reaction without an enzyme. So without an enzyme, the activation energy, like this right here, it's really high. Okay, but what an enzyme does is it lowers the activation energy. Okay, so that's essentially how it works. There's less energy that's needed for the reaction to occur, so it can happen at a faster rate. So same amount of energy can be used, multiple times, and sometimes up to like it ends up increasing the rate up to like 1,000,000 times. So the activation energy is lowered, which makes the reaction speed up. Okay, so next thing that we need to talk about is what factors affect enzyme activity. First thing that we have is temperature. So again, we talked about how enzymes and substrates they collide, and it's based on molecular movement. So they're both moving around in a liquid, and they collide. So what happens as the temperature increases, so does the rate of reaction. And that's because as temperature increases, the molecules within the liquid start moving faster and faster and faster. And so that causes the substrate and the enzyme to collide more frequently. Okay. Eventually, it will reach what's called the optimum temperature. So every enzyme has an optimum temperature. And so that's the temperature where the enzyme works best. But then what happens is we have a decrease in the rate of reaction, because what happens if it gets too hot, the enzyme, will denature. So denaturing, let me see, there's not a lot of room, but like denaturing is, I'll write this down. Denaturing is when an enzyme loses its shape, and it's irreversible. So, irreversible. Okay, because once it gets too hot, the enzyme will denature, it will lose its shape, and therefore, in particular, the active site will lose its shape. And think of it like a broken egg. If you break an egg, you can't put it back together. If an enzyme denatures, you can't put it back together. So denaturing is irreversible. Okay, so eventually the rate of reaction will eventually just stop once all the enzyme is denatured. So that's temperature. With pH, it's essentially the same thing, but every enzyme has a different optimum pH. So, for example, we have in this picture, or in this graph that I made, we have like a protease which is within the stomach, and the stomach is an acidic environment, so its optimum pH is going to be a lot lower because the stomach is acidic, whereas lipase forms in the pancreas, and it breaks down fats that are in the small intestine, and the small intestine is a lot more basic. So lipase is going to have an optimum temperature that is a lot more basic. Okay, and same thing with temperature, although it happens on both ends of the spectrum. So if the pH is too acidic or if it's too basic, then the enzyme will denature. Again, it will be destroyed because the active site and the enzyme itself will lose shape, so the substrate can no longer bind to the active site. Okay? So too high or too low pH will cause the enzyme to denature. So that's pH. Let me do this in like a different color. There's pH. Okay? And then last thing that we'll look at is substrate concentration. So what happens when substrate concentration increases? And so what happens to this is the reaction will initially increase as collisions happen more often, because there's obviously more substrate to bind to the enzymes. But eventually we're going to kind of reach this plateau, which is basically as fast as the rate of reaction can happen. And this is because eventually all the active sites are going to become occupied and unavailable. Think about it. If you think about it logically, eventually all the enzymes are going to be doing work. They're going to be used up. And so the reaction is still happening, but there's eventually going to be a substrate concentration where it's just kind of working at its full capacity and it can't work any faster given the same amount of enzyme that's present. So the active sites will become occupied and unavailable until the products are formed and released, and then, the reaction can continue. But eventually it is going to reach this kind of plateau. So next we have to talk about enzyme inhibitors. So enzyme inhibitors are chemical substances, basically molecules, that can bind to enzymes and reduce the activity of enzymes. So we have two types of inhibitors. We have competitive inhibitors and non-competitive inhibitors. So the first one, competitive inhibitors, basically mean that these inhibitors are going to bind to the active site or part of the active site so that the substrate cannot bind at all. Or it can, but it will happen less frequently, is what I should say. So that's competitive inhibitors. And then non-competitive inhibitors, what they do is they actually bind to another location on the enzyme. And when they bind to another location, like down here, this changes the shape of the active site. And I apologize, this is not my best drawing ever, but so, oops, my pen just went away. It just died. Okay, so like this normally is kind of what the active site looks like, but as you can see, once the non-competitive inhibitor binds, you see that the active site shape has changed, so the substrate can now no longer bind at all to this enzyme. Okay, so with the competitive inhibitor, potentially, yes, like the competitive inhibitor can kind of leave and the substrate can bind again, but with the non-competitive inhibitor, it changes the shape of the substrate, so the enzyme can no longer fit. So this is kind of what the effect looks like if you look at the graph. So a normal enzyme, just like we talked about, same thing up here is down here. So normally there eventually is going to be, with a normal enzyme, a maximum rate of the reaction will occur. And so with a competitive inhibitor, that same maximum rate will happen eventually. It will just take a longer time. Okay? So the maximum rate can still be achieved, it'll just take longer because the enzyme or the substrate can still bind to the enzyme. It's just gonna happen less frequently. However, with a non-competitive inhibitor, the maximum rate of the reaction actually changes and decreases. So it does not reach, that should say reach, I'm going to change this, does not reach, does not reach the same maximum, because what happens is the inhibitor is going to change the shape of some of the enzymes, and so the substrate can no longer fit into the enzyme regardless of how much substrate concentration there is. There could be tons and tons of substrate, but if the substrate can no longer fit in the enzyme, well, it's not going to be able to reach that maximum rate, like with the competitive inhibitor. So if you look at a graph like this and you see the normal enzyme rate and then you're given one of these lines, you should be able to figure out which one is a competitive inhibitor and which one is a non-competitive inhibitor. So remember, competitive inhibitor is going to reach that maximum rate, but the non-competitive inhibitor will not reach the rate. The maximum rate will be decreased. Okay. All right. Second to last thing we need to talk about, it goes along with inhibition, but so sometimes a lot of times in organisms we have this thing called end product inhibition, and so this is a way to kind of naturally inhibit metabolic reactions. Remember, metabolism is like all of the enzyme reactions that happen in a organism. So these are called allosteric interactions. And so what happens is enzymes are regulated by non-competitive inhibitors. Okay, and so what happens is, so let's use this example of threonine and isoleucine. So these are two amino acids, and one amino acid can be converted into the other amino acid, isoleucine. So we have, if you look at this picture, we have the initial substrate, which is threonine, and it binds to the active site. There's some intermediates, but eventually what you're going to get is isoleucine. Okay, so threonine is converted into isoleucine. Once you have enough isoleucine, then what's going to happen is the isoleucine will then bind as a non-competitive inhibitor to what we call an allosteric site that is on the enzyme. Okay, and so that will change the shape of the active site on the enzyme, so threonine will no longer bind to the enzyme, okay, which effectively stops the reaction from occurring. And so the purpose of this and why this happens is it prevents the buildup of intermediate products. So if we have enough isoleucine and we don't need any more, then this end product inhibition will occur, so that the intermediate products don't build up and there's not like a buildup of too many intermediates, and they're just kind of unused. So last thing that we're going to talk about is immobilized enzymes. So immobilized enzymes are kind of used in like biotechnology. And so the example that we can use is there are immobilized enzymes that are used in the production of lactose-free milk. So what immobilized enzymes are they're enzymes that are attached to a material so that the movement of enzymes is restricted. So the enzymes can be attached to like a glass surface, they can be trapped into a gel, they can be bonded to other enzymes. And again, the purpose of this is you want to be able to reuse the enzyme over and over again, and it's easy to separate the products from the enzymes. So here's a picture to kind of help you visualize. So let's say we want to make lactose-free milk. What we will do is we will take the milk that contains lactose, we will kind of pour it through this filter, which has beads, immobilized. So the beads, or I should say the lactase, which is going to break down the lactose. So the lactase enzymes are bound to these beads. And so when the milk goes through this filter, the lactose will be broken down by the lactase, and then what you have that comes out of it will be the lactose-free milk. Okay, so that is your last example, and that's all I have. I know this is a lot of information about enzymes, but enzymes are super duper important. So if you need to, make sure you go over this again, and go through some of the worksheets. And obviously, you can always ask questions.